Since its emergence in the late 19th century, fingerprinting has been used in many different ways in applications that have ranged from the verification of identity on documents to forensic crime scene investigation and even to medical diagnosis. Some of these uses remain important today. The examination of latent fingerprints, for example, remains a crucial area of forensic science. Other applications of fingerprinting, especially in anthropology, genetics, and other life sciences, have receded in importance. The rise of DNA profiling has been a major development in forensic science and has affected not only how fingerprinting is understood as a forensic discipline, but also how its strengths and weaknesses are evaluated. Since its emergence in the 1980s and 1990s, DNA profiling has increasingly come to be seen as a kind of gold standard of forensic science. This point was made, for example, in the 2009 report of the National Research Council of the National Academies, Strengthening Forensic Science in the United States, A Path Forward, which praised the methods used in forensic DNA identification while questioning the scientific basis of other forensic disciplines, including latent print evidence. DNA profiling is viewed as such an authoritative forensic practice because it originated in the academic field of molecular biology and relies on data drawn from population genetics as well as sophisticated understandings of probability. By contrast, the forensic use of fingerprinting was always largely associated with the knowledge and expertise of police officials, not academic scientists, and the methods that they used to make fingerprint matches suddenly looked much less sophisticated than those that were used in DNA typing. While latent print evidence remains an important and widely used forensic discipline today, its scientific basis continues to be developed, in part driven by these critiques. There has been a real interest over the last few decades in developing methods that can make fingerprint identification more accurate and reliable. For example, by formalizing the procedures that are used to analyze and compare prints, by gaining a better understanding of how common or rare particular fingerprint characteristics are within the population, and even by exploring methods that could be used to assign probabilities to fingerprint matches. Looking back over the modern history of fingerprinting, we can say that the development of this technique has been driven by many factors, everything ranging from attempts to expand state power in the colonial context of 19th century India to the influence of scientific disciplines like physical anthropology, genetics, and now molecular biology. Innovations in the technical practices of fingerprinting have also played a role, whether it was the creation of new ways of classifying fingerprints or the rise of new technologies that have transformed fingerprint records from paper-based files to digital information that is now stored on computers. Ultimately, as forensic science professionals and researchers continue to develop fingerprinting as a field of knowledge and practice in the 21st century, it is worth keeping in mind the complex interactions between policing, law, science, and society that have shaped its history from the very beginning.